first, but anyhow. All right. It is the top of the hour. Welcome to the Global Math Department, everyone. My name is Lee Natero, and I'll be your host tonight. Tonight, we're going to hear from the folks at Public Math. Their topic is Public Math Pop-Up, Mathematize Your Kitchen. Would everyone please introduce themselves in the chat, telling us what you teach, where you teach, and what your Twitter handle is, if you have one.
I'm on the edge of my seat. I don't know about you two.
I'm standing, so.
I'm typing. I'm answering those questions. Do we know? I'm confused. Do we scroll up or down on the? Oh, here we go. I got it.
Here they come. Here they come. Romania.
Nice.
Yep, I told you we are definitely a global community. We often have people here from Indonesia, Canada, Australia.
What time is it in Romania right now?
Yeah, when I say good evening, it's definitely not evening in Romania. Philippines, it wands off in here. This is true. All right, so before I turn this session over to our speakers, let me explain how these meetings work. These meetings are recorded and are available within 24 hours after the meeting ends. To view the recording, you would use the same URL you used to get here tonight. The Global Math Department community prides itself on being friendly and supportive. The chat room is available for topical and general conversation throughout the meeting. I'll catch your questions for the presenters, so don't worry that they won't notice your questions in the chatter. And now I will let the speakers introduce themselves.
All right, I am Molly Daly. I am a regional math coordinator in Vancouver, Washington, so the other Vancouver, not in Canada. And I direct a project there called Math Anywhere, which is kind of a kindred project with Public Math. And I'm also the first chairperson of the Public Math Board of Directors.
Woohoo. I am Christopher Danielson. I work at Desmos in curriculum development, former middle school and community college teacher, and am the executive director of Public Math.
And hi, everyone. My name is Chris Snow. Currently, I teach 9th grade at High Tech High in San Diego. Hi, Sarah. Thanks for being here. And I am the creative director for Public Math. And what is Public Math? You're going to find out today, and you're going to find out by doing, not necessarily us just telling you about it. And so I want to direct your attention to a Desmos activity that we've made that's going to kind of be where we don't have a presentation made for you in the PowerPoint sense, but we have a presentation made on Desmos. So we'll be sort of interacting and talking back and forth. If you're not familiar with what Desmos is, it's like a teacher activity page to interact with students, see their thinking. And so I'm going to drop that link in the chat right now. And it's also up there at the top of the chat, pinned to the top. You can go ahead and click that if you need to. And once you log on, you should be taken to a page with a picture of a blender.
Yeah, as well as one counterfactual statement, because I typed up the note and then got excited about one more verb. So there's a bunch of verbs there, and we would invite you to put them in order from slowest to fastest. There are actually 14 speeds on that blender, but we thought it might be a fun little game to see how likely we are to correctly identify the 14 speeds. I'll give you a moment for that, and then I'll say a little bit about why this is an amusing task for me, what it has to do with math.
Sarah Strong with a strong ranking. I know Sarah does a lot of blending at home, so she, jumped right into this task, no hesitation.
There are no wrong answers to this task, but there is one right one.
I'm going to need that. I'm going to need that expounded on, but maybe for another session.
Oh, boy.
Wow. Team Chop coming in strong. This could also be like a March Madness bracket style. That's another universe in which this lives.
Yes. Yeah. So let me see if I can remember. Oh no, we can find the. Can we find? I don't think I can find the answer key. I've always been amused by blenders because we have these 14 different speeds, which, first of all, I'm not convinced that they do anything except make different sounds. But we have these verbs, and like the verbs don't actually map onto speeds in any way that anybody can predict. So my prediction here is that pretty much nobody gets any of these right. The original version we typed up had all 14 speeds, which leads to 14 factorial possible combinations, only one of which is correct. Yeah, you'll have to go Google it. It's an Oster blender. Just Google it, hit the images, and zoom in, and you can find out. I do remember that the fastest one is Ice Crush. Seemed unlikely that anybody would know that.
A lot of liquefies. We're seeing a lot of team liquefies as the fastest there.
Yeah, no, that's right behind Ice Crush. I believe liquefy is 13 out of 14, and Ice Crush is right up there at the top, but the 14th, the very fastest of all speeds.
Yeah, I'm with Sarah in the chat with a what? Like, wouldn't you crush ice before it becomes liquefied? Come on, Oster.
I don't know.
Come on, Oster.
I don't make the rules. I just enforce them. Yeah, so we're going to mathematize our kitchens today. We thought we'd just start off with a silly little task that has to do with my original thinking was that this activity would be titled the well-ordered blender, thinking about well-ordered sets and how these verbs are not well-ordered sets because nobody knows what comes after the next one. So we thought we'd start off with a silly little like greater than, less than ordering kind of task and move into something that we know everybody can participate and be correct at. And that, my friends, has to do with the eggs that may be in your refrigerator. Maybe you don't have a refrigerator. Maybe you don't have eggs, in which case we're going to ask you to imagine. Just imagine you've got you have a refrigerator with some eggs in it. But if you do, we would really appreciate having you go to your refrigerator in just a moment. Not just yet. We want to set this up. And so what we're going to ask you to do is you're going to go to your refrigerator. If there is one that has eggs in it, you're going to pull that egg carton out and you're going to take a look at the arrangement. I have 6 eggs in my refrigerator right now. Actually, it's not true. It's 18 plus 6. 24 eggs. Arranged in 2 cartons. One is your standard dozen, and there they are. From what I understand from egg Twitter, math egg Twitter recently, like this is just an unacceptable way to arrange your eggs. It has a nice symmetry, but people seem really concerned about it having balance. So don't turn me in. And then I also happen to have got the full 18 that we haven't gotten anything out of yet. So we're gonna ask you to go to your fridge, and maybe you're the kind of person who likes to get fancy with photographs, in which case you can take a photograph and you can upload it through the Desmos activity. Or maybe you're the kind of person who likes to draw a picture. Doesn't matter. We've set it up for you. So when you click ahead, have we let them? Yep, we've let you go to that second screen. Go to screen 2. And we've set up a few possibilities. We've got your standard 2x6 egg carton. If you've got, like I do, you've got one of those 3x6. There you go. We got that ready for you. 5x6. Maybe you've got the big 2.5 dozen 30 egg extravaganza in your fridge. That'd be awesome. We got that set up for you. And maybe yours are in like a 3x4, or I know in countries outside of the United States, 2x5. I have an Icelandic egg carton that's 2 rows of 5. It's a 10 frame. So great. So we gave you a blank one that you can sketch on. So you can make a sketch of how your eggs are arranged, or take a photograph, whichever you prefer. We're going to pause for you to do that. I'll stop talking. Go team. We'll see you back here in about 2 minutes.
Lee in the chat with the vegan just eggs. Love it. Let's see it. Let's see it scrambled up. Oh, no photo upload available. Interesting.
Oh,
maybe just sketch then.
That's on us.
Yeah.
Apologies. Sketch only.
But the sketches are coming in hot. Wow. You know, you think you can anticipate what people's cartons are going to look like, and you just can't. Trevor, you got to eat some eggs. You got to get that protein.
Yeah, I'm curious, Chad, those are where your eggs are or where they aren't? Oh, you can't see everyone else's work because we can only see it because we are the teachers here. So we're looking at our dashboard. Chris, are you able to share a few of these layouts?
Yeah, I wanted to give just a couple more seconds.
Okay.
I think people are still finishing up, but Claire, we're going to share some with you. Wow,
Emily's got the full set. 30 eggs, none have been used.
I don't believe that. I'm going to need photo evidence emailed to our public math email. Maybe take 30 seconds here. Oh, wow. You know, the timing with Easter here, I think that's what led to a lot of interesting.
Yeah, there's a lot.
Yeah.
And also maybe just some larger than average egg containers.
Mm-hmm. Okay, I have some snapshotted, so I'm going to start arranging those.
Do you have Latrendas? I love Latrendas.
Oh, yeah. Yes, yes.
Sorry, we're just teasing our participants at this point. Oh, Evita's only got one.
Where do you see that one?
We could have a. She says so in the chat.
Mm-hmm.
So now I'm wondering where that egg is. Upper left.
And the egg frittata requires 11 eggs. My goodness. Oh, Francis with some strategy here. Okay, I'm ready to share screen. Should we? Here we go.
Yep, that's it.
Oops. Boom. All right. I think now you should be looking at some folks' responses, and you can chime in here in the chat. But this is Erica. I think we've got a standard strategy here. This looks like a little bit like what Christopher had, but interesting to see it slowly maybe morph into that. Would love to know, Erica, how it got there, what that strategy was. Here's another one. This one was from Tom. Random teenage behavior.
That'll cause problems.
Yeah, I mean, Christopher, you are the parent of teenagers. Do you see random teenage behavior like this?
They don't. They cook usually with one of the parents, or like putting stuff together. They don't use a lot of eggs on their own. So I wouldn't be surprised if like one or the other of them. They're 14 and 16. I would not be at all surprised if one or the other of them, like on the rare occasion that they do pull out an egg, like strategized about how to make it aggravating for one of the other parents.
I think once you take this one, it's like game on. You know, it's like what, I dare you. What's the next one gonna be? So beautiful. Thank you, Tom. Let's just. Oh, this one.
That's hot.
Wow. Yeah, what do you think is Latrenda, and if I'm pronouncing your name incorrectly, please correct me in the chat. But it'd be awesome if you could contribute in the chat here some of your thinking. But what do you think, Molly? What do you think, Christopher? What's going on with this picture? What are you seeing?
I'm seeing some nice boundary and interior, like area perimeter boundary kind of stuff going on there. It's super fun.
I'm anticipating the next egg to go might be that other one
Ooh.
left in the middle.
Oh, right.
Maybe.
Yep. Nice. Strong guess.
Yeah, I actually think this has a lot to do with like handling the carton of 18. Like you want to create that strong border. Really love this one.
Like, do eggs weaken or strengthen? like holding my 6, right? And I'm trying to decide.
I'm thinking
if I hold on the unegged side, then I've got all the egg weight that's pulling down. It feels a little bendy. But if I'm holding on the egg side, Yeah.
This is the eggs of Konigsberg, I'm pretty sure is what this is called.
Or she's balancing the weight and is going to move them on the end. They're going to go to the middle. Surprise answer.
This one is nice. I think, Paolo, this was, these markers indicate the eggs that do remain in the pack of 18. Oh, Latrenda, right there in the chat. Yeah. I was trying to balance the weight, and I will probably move some of the ones on the end to the middle. Wow. Thank you for letting us peek into your kitchen like this.
Hey, Chris, quickly, don't go back to Latrenda's arrangement.
Okay.
How many eggs were in her carton?
Ooh, okay.
Do you know?
-3 is what I think. I think there was like a gap of 2 and a gap of 1. So nice. I'll say 18 minus 3, 15, but
yeah,
lots of other ways to count.
Yeah, because I remember there were two full rows, top and bottom, and then the ends and the one in the middle. So I added, you subtracted.
Ooh.
Sarah says 18 minus 2 minus 1.
Nice.
Nice. Here's another one, and then I think I just snapshotted one more, but there's a lot of goodies in here. Wow.
I like the key. I like the key. That's strong.
I feel like that's a two-handed. You got to use 2 hands to get this out of the fridge, maybe.
No, you grab it under the eggs, and then there's like no weight over on the rest of it. You're good.
I'm using 2 hands.
I feel like it must be like this is the back of the fridge, if that makes sense, because you can't reach, like you got to reach to the thing closest to you and grab it,
Sarah's, that one's going on the floor.
Yeah, right.
The loner up top.
Okay. All right, I'm going to stop. Actually, no, I'm not going to stop sharing because this is a slight introduction to what we're doing today. And man, maybe we'll look back at some more if we have some time remaining, but I'm going to move us on to the next screen here. And Molly, please take it away.
Yes. So what is public math? We were just sharing, we answer this question differently each time we answer because, it's very intricate endeavor. But what I would say is that public math is, and you can see our contact info there, where to find us if you're not familiar with us yet. But we are officially a nonprofit, and we're made up of a collective of artists, educators, other interested collaborators. And we like to provoke math, thinking, or doing in public places. So maybe ideally, I guess, where you wouldn't expect it, or you might find math to be surprising. But really, if you think about it, and if you start considering it now, you probably already are doing a lot more math thinking and doing as you go about your life that doesn't necessarily get acknowledged. So I'm going to have Chris click forward to the next image. And we think about that to put it in one term as mathematizing, or regarding a situation or object in mathematical terms. And I think a lot of times we do this, but we don't necessarily share it with anyone else, or maybe we're not even conscious of it ourselves. So for instance, I like to motivate myself to get up in the morning by, I tell myself I have to get up before the minutes is the next multiple of the hour. And it's just a way of giving myself 5 more minutes without, because I got to get up before 6 minutes, without, just make it interesting, I guess. Or maybe for you, it's the dishwasher in your house. Maybe you have an order or an arrangement that you like that uses size and shape and orientation, and you don't want anyone messing with that certain order, similar to eggs, I guess. So a lot of times, as I said, we're doing this internally without sharing. So you probably have an inner mathematical life, and so does your significant other, your children. Everyone probably has these math ideas they're exploring on their own. So I asked my husband, Greg, yesterday, because again, these are often things we don't talk about. I said, how do you mathematize in your everyday life? And he shared that there are 17 stoplights on his commute to work. And he likes to keep track of his success in hitting green lights in terms of a batting average. So that's how he thinks about it. And he knows that if he goes 0 for 3 on the first 3 lights that are between him and the freeway, he's going to add on actually an extra 10 minutes to his commute to work. So it's kind of important that he has some success on those first 3 lights. So he said the best he's ever done is 14 out of 17, so an 823 percentage. That's pretty good. He's never batted 1,000, but he knows that he's hit 14 out of 17 lights. So for us at public math, those are the kinds of things that this math that happens outside of the classroom, math that we do in our everyday lives or everyday situations, is the math that we're interested in elevating, promoting, drawing out, and really putting it on equal footing maybe with the math that happens inside the classroom, which a lot of times gets prioritized. So we like to uncover these things, share them out. And then one question that we hover on a lot is, how do we share these math curiosities in ways that can engage others or get others to interact with them? Because I'm pretty sure, my husband teaches middle school math, but if he showed up at school, sharing his batting average for his traffic lights, I'm not sure that his students would have curiosity about that. So it's, how do we share these inner wonderings we have in ways that are interesting to others?
And with that, I'm going to take over here and talk about like 2 things I think we've used as sort of a framework to think about how to do public math, how to invite folks to see their own inner mathematical lives, to invite others to see mathematical lives in them. And we've come up with a couple terms here that we have found helpful. And each of these terms, we've kind of attached an image. And Molly and Christopher, feel free to dogpile onto whatever I'm saying here, because I think the more we talk, maybe folks can get different things out of it. So the first word here is layering. And maybe what I'd love for you to picture right now is like a picture of a laundromat. And what we're going to do is layer onto that picture some mathematics, layer onto the laundromat some mathematics. And so this is a project that we did in Chicago where I had a friend who owned the laundromat, and I asked him if we could spend a weekend mathematizing it. And we did. We reached out to Dan Finkel, who's the creator of Prime Climb, and he has these really fun ways of really fun game of like coloring numbers depending on their prime factorization. And what we did is we noticed that there were numbers in the laundromat that they used to just keep track of which machines were in use. And we converted those numbers into Prime Climb numbers. As you can see from that picture, we included some prompts on some of those numbers. This one is asking people to find another one that's made with just green sections. And so this didn't exist before in the laundromat. And what we did was layer it on to that experience. So that's layering. And that might be one helpful way to think about mathematizing your kitchen, mathematizing your staircase at school, mathematizing the playground outside. How can you put math there when it wasn't there originally? The second term is eliciting. Or enhancing. We haven't really settled on one yet, so maybe you can let us know in the chat which one resonates with you more. The photo you're looking at right now is something called the number game, and it was created by Christopher over here for Math on a Stick at the Minnesota State Fair. And what would happen is people would show up to the booth, or in this case, the library, and they get a little card front and back there, and it asks them to find these numbers in the fair, or in this case, the Chicago Public Library. And so you can see these numbers are like 0, 0.1, 1/2, 2/3, and there's multiple lines to invite multiple units or multiple things to find of that quantity.
Yeah, and one quick clarification just about that particular game is that you're not looking for the number 1, you're looking for 1 of something and 1/10 of something else. I could imagine like in a library, people wanting to go looking for the Dewey Decimal System. That's not what this is about.
Perfect. Yeah. And so what is this? Like 1 dozen computers, as an example. Too many books. Ouch. This is kind of This is a real response that we got. About 1 million pages. And so this one was one where we kind of invited in estimation and things like that. But this is an example of what we think is us eliciting or enhancing a space or a place. So a library exists, and from our lenses as math educators and creative folks, we saw a lot of mathematics going on. There's so many fun quantities of things in a library. And so all we did is we didn't need to layer onto the library more math for folks to do. All we needed to do was create a prompt, an invitation that got folks to see the mathematics that was already there. And so we thought the number game was a really good example of that. Layering or eliciting, enhancing, Christopher, Molly, any other things you want to add to that?
I think where I'm starting to settle down on this is that enhancing is what we do to the environment, and eliciting is what we do what we do in cooperation with people. So I'm going to elicit from, like we elicited from our colleagues, our attendees today, some math about the ways in which their eggs are arranged. We didn't do anything to their environments. Their environments look exactly the same. Whereas, if I go and trace some existing shapes with a piece of chalk on a sidewalk, I'm enhancing something, bringing something that exists in the environment, maybe make it easier for people to see.
I like that. Okay.
I'm not ready to settle because it's more fun to talk about than, decide. So, but I always think about, yeah, exactly. And, math only exists to the degree to which we agree on definitions and that kind of thing. So we can keep arguing about this one. But I like eliciting just because I think about, especially with Math Anywhere, there's quantities around us, shapes around us, all these things in the environment that we're kind of drawing out. We're not really, through the number game, we're drawing out quantities. They're already there. So that's kind of why I like the word eliciting.
So catch us next Global Math Department where we might have stuff more figured out. Or not. All right, so we're going to kind of play, I think, with these ideas, what Molly mentioned, these two strategies we have at Public Math for mathematizing spaces. And we're going to do that in the context of our kitchen. So I'm going to zap us here to screen 7 on your Desmos activity. And Christopher is going to share a story about a microwave.
Yeah, actually, we're going to do two things. I'm going to do two things. First thing is, as example of layering, we have a little giveaway tonight.
Oh.
Do we not?
Yes, we do.
We do. So one of our most recent projects we've been playing around with the question of what would it be like if you could deconstruct your geometry book, take apart a high school geometry text and not have each of those vocabulary words be so precious that has to be used in a particular way. But what if you could start talking about isosceles angles and perpendicular angles and just all kinds of fun stuff. So we settled on magnetic poetry. And it turns out that we were about 2 weeks into this process when we learned that there actually exists a mathematical magnetic poetry. But what it really is like math processes. It's not so much, the one that exists isn't so much like just pulling apart tons of geometry vocabulary. So we have custom ordered some math, we're calling it deconstructing geometry. And it now exists. There we go.
Boom.
So if you're a person who's comfortable with ambiguity and comfortable with like thinking about mathematics as being about rule breaking, this is tons of fun. And so they're shipping this week, and we're going to give 2 sets away. Is that right? 2 randomly drawn attendees. We forgot that we'd have international people, but I feel we could do this. So if we randomly draw you, we will send you an email, and you'll write us back, and we'll ship it out to you. It could take a while to get to the Philippines, but if you're if we randomly draw you, we'll play fair. We'll get it there eventually. So that's an example, like another example of layering in the kitchen. The reason, by the way, the reason we're in kitchens today rather than in some other public space, like we introduce ourselves, hey,
Yeah.
what's it like to find math in unexpected public places? Now let's do stuff in our kitchens, and we're going to design stuff for our kitchens. And it's because, friends, we are hopefully coming to the end, but still certainly in a global pandemic in which the notion of public spaces a year ago got radically changed. So that meant a lot of changes for our work. Most of the work that we do at Public Math, like the idea of Public Math, sort of came out of a large-scale family math play event that I've been helping to organize in Minnesota at the Minnesota State Fair for the past 5-6 years. And we started thinking about what would it look like to design some other playful math experiences for other public places that would have different constraints, different affordances, might help us reach different kinds of audiences, do different kinds of mathematics. And so a year ago, we had to step back, and as everybody else did, and say, so what does this mean for our work? And one of the things it meant for our work was Project Postcard, in which we invited people to head to our website, and sign up to send themselves or a friend a postcard, because we know that the mail is still going into people's houses, but public spaces where people are gathering were much harder to come by. And so also the last year, we've been thinking about, okay, people aren't getting out into the world quite as much. So how might we invite people to see the math that exists in the spaces that they're spending much more time in than probably previously they had? And kitchens are just fun. You know, everybody has access to some kitchen, or you know, if they're in some kind of communal living environment, they certainly have had access to a kitchen in their lives. There are some common expectations, but enough differences that I think there's a lot of fun to be had there. So refrigerators are a place where you can play with magnetic poetry as a layering experience, right? These words weren't previously there. Nobody was doing geometry on the front of their refrigerators, and now we're putting those magnets in place. We also want to talk about a little bit of the enhancing or eliciting side. And so we are operating from an assumption that may not be true. We have an out if it's not true, but the assumption is that you either currently have a microwave in your kitchen, microwave oven in your kitchen, or you have been in a kitchen on a regular basis at some point in your life that had a microwave oven. And if neither of those things is true, then you probably have some other device in your kitchen that has a button on it. It might be electronic, it might be mechanical. You might freely interpret button. We're fine with that. We're loosey-goosey around here. We want to expect and prompt as much creativity as we can. But basic assumption is microwave. I'm going to tell you a story about my microwave oven and some mathematics that we did around my house with a microwave oven. It's a lot of it is still in that sort of personal headspace, trying to help elicit from each other and share with each other some of the mathematics that we do on a daily basis that might not get spoken about. And even if it gets spoken about in the house, being able to see inside somebody else's home and hear their stories can be interesting and powerful as well, both mathematically, but also as, you know, a social connector. So this is not the story that I'm about to describe is no longer, its consequences are no longer a factor in my home. But when my daughter, who is now 14, was probably about 10, she was tall enough to reach the microwave that was over our stove. She could put her soup in. Girl loves her soup, still does. Full bowl of soup in there, closes the door, punches the buttons to get it started. And it seemed to her that on a sort of unpredictable basis, she would have to drag a chair over there, stand on the chair, because the thing that rotates inside of the microwave would rotate her soup to the back of the microwave. And this was frustrating, both because she had to drag the chair like it's extra work, but also because she's reaching all the way in there. Now she's got this bowl of hot soup and she's standing on a chair. Like, this is just not an ideal situation for a 10-year-old to then have to get down. And you don't want to go to the extra step when you're 10 of putting the bowl of soup down, getting down off the chair, then carrying the soup over. So she had a problem. And I thought the math might be able to help us with this problem. She was skeptical at first, but I won her over. And the solution to the problem was, let's see how long it takes to go around. That thing rotates. rotates at a constant speed, like it's not speeding up, slowing down. It's not a jerky movement. It's a nice smooth movement. See how long it takes to go around. I don't know. I have no idea how long it takes to go around. So we timed it 20 seconds. And that meant that putting it in for 50 seconds was kind of a bad idea because her soup would end up at the back. It'd go around twice and end up at the back. So if she puts in for 20, 40, 60, 80, any of those, everything's going to work out great. So everything's going along fine. Problem solved for a while. And then one day, I don't know, 3 months, 6 months later, we're both in the kitchen. She's making her soup. And she's like, watch this. She puts the soup in, pushes it all the way to the back of the microwave. She could do that. She can't like lift it up, but she could put it in, push it all the way to the back, closes the door, punches in, 50 seconds. Goes around twice. Comes up to the front, ready to go. She had determined that 40 seconds was not long enough to get the soup hot enough. 60 seconds, too long. 50 seconds was the right amount, and took the extra step to make sure that put it all the way to the back, it'll come around the front. So a lot of math happened there with a 10-year-old. And well, I mean, for me, one of the beautiful things is that she took it, ran with it, did that next step, problem solving. A lot of fun stories we've told about microwave ovens and the math we do, but don't always have a chance to talk about around the public math headquarters. So we're now going to invite you to tell us a story on screen 7 about a microwave, a button on your microwave, an activity within your microwave. Maybe it's a microwave of a friend because you don't have a microwave. Maybe it's one you remember. Maybe it's some other button in your kitchen. Let's give people about 4 minutes to think about what kind of story might you tell, and give us a couple in the notes there. I'm going to mute myself.
We're getting a couple just like first sentences coming in, and I am excited. A lot of people throwing shade on their significant others or the people that they live with, like, oh, this person does. SB Vaughn with a classic right there. Sarah with the open questions. Everyone has a microwave math story, every time we ask. Oh, washing machine story. That's a great button story.
I'm seeing a lot of love for the plus 30 seconds button.
Mm-hmm.
Our old house, we moved 2 years ago. Our old house had a plus 60 seconds button.
Too much.
I don't know. It took a while to adjust. I mean, how often do you need? I feel like it worked out pretty well. Because if I want 90 seconds, I'm no fool. I was typing 90, typing 88, enter, boom, good to go.
I have a couple snapshots here, but why don't we wait like 30 more seconds, get those stories in, get those buttons in, and Christopher, if there's any that you're seeing that I haven't snapshotted, let us know. Let me know. Oh, wow, Trevor, that is precise. That's a SMP, I'm pretty sure. Standard for mathematical practice.
I appreciate we're inspiring at least some people to some scientific experiments.
Yeah, this is more like science, microwave science.
There are buttons I haven't pressed yet. I've got 2 different ways I can defrost stuff. Should I do it? I don't know which is better. Maybe I should do an experiment.
All right, let's look at some, shall we? As a whole little team here. Ba-boom. All right, I'm going to start here with Erica's. Erica wrote, I never punch in the actual time it needs and instead only use the plus 30 seconds button. So I think this is what Christopher was mentioning here. And look at this, hashtag unit chat. I think about all food cook times in terms of 30-second intervals or groups of 30. It's really amazing.
Is that true? I'm curious whether that's true for all cooking methods now. Like I'm boiling eggs.
It's
I'm
like
supposed to
5
hard boil
buttons.
my eggs for 10 minutes. I'm thinking, nope, that's 20
buttons.
20 half minutes.
Yeah.
Is how long I'm gonna cook those eggs on my stovetop.
That's nice. Okay, here's another one too. I don't like to push multiple buttons, so I choose times like 44 seconds, or look at this math worked out. I will do 444 needs around 5 minutes. Wow.
Whose was that?
We got to give that shout out to SB Vaughn.
SB Vaughn, I'm dying to know, what do you do in the odd circumstance that you need 10 minutes of microwave time? What do you do?
Let's see that may be open challenge for everyone in the chat. 10 minutes of microwave chat. What are you jamming into your keypad?
Ooh, Sarah.
Ooh.
Sarah's going over. Oh, Sarah is SB. Got it. She's going over. $9.99.
Will it accept 99 as a seconds input?
Yours will, Chris. I know this about
Oh,
your
yes. You have the same microwave. Christopher inspired me to get a microwave in this new house I just bought.
Inspired him to buy the house so that he could have a microwave.
I was like, I want to be part of the club.
Yeah, I'm an 888 guy. I'm happier to be, a little under than a little over. There was popcorn was mentioned.
Oh yeah, we've got that too with popcorn. I like SB Vaughn's Sarah's answer there because it really highlights the efficiency that we think about. You don't have to move your finger around. You don't have to think. Oh, Sarah right there taking the call from the kitchen too. Thanks for experimenting. Here's Meg's answer. My partner always stops the microwave with between 11 to 13. Look at that tight range. That's a 3-second range that the partner is always leaving it with. It drives me crazy because then he doesn't ever clear the remaining seconds. Let's see. He says he just likes knowing he has the option. Oh yeah, plus or minus 11 or 13 seconds.
Yeah, but if it's plus or minus, like if you put in too few seconds, then you got to go put more in. So yeah, it's an instance of rounding up.
Yeah, and it's like if he wants to microwave something for 1 minute, does he put in 113 and then it starts?
111 maybe.
Oh, okay, I like that. I like that.
Finger.
Another classic from Latrenda. This is that defrost by weight versus defrost by minute. Holy moly! We're gonna need a status update on that. Send us an email. We might throw in a magnet kit, but we got to know. We've got to know what those two buttons are all about. And then here's one. This is that popcorn story. Popcorn burned the popcorn slightly, and then so there was an experiment ran and ended up on 2 minutes 33 seconds. And that popcorn button, I feel like we all have it, and it is, and nobody uses it. No one
don't
uses
trust
it.
it.
I'm in a family of popcorn button users, and they say it works on our. Yeah, I've never tried it myself, but the fellas in my household just like that popcorn button.
We haven't talked about like power levels. I guess that hasn't really been brought up here, but I think that's a whole nother can of worms. So Okay, that's all the microwave stories I snapshotted from long ago, but anything else?
Beautiful collection.
Yeah, pretty good. All right, I think we're going to wrap up then with one final screen on this Desmos activity. I think when we were planning this session for Global Math Department, we thought about eggs, we thought about microwaves, and we've done this with other things like kitchen timers, things you have in your utensil drawer, so on and so forth. But we actually wanted this last part to just kind of turn it over to you. Let's say, actually, not let's say, you are public math, okay? And you're planning this session with us now. So we want you to go and actually invite us into a mathematical invitation in your kitchen. And so we believe that all objects really do have the potential to be math objects. And it's just a matter of the way you see it and the way you can invite others into seeing it that way. So whether it's through layering, maybe it's a thing that you have that you want to layer onto, or enhancing, taking a thing that's already there in your kitchen and bringing it out. We'd love to know what's an object in your kitchen and how do you see it as a mathematical object? These responses, we're going to do a similar thing where we collect them, share them out, and we're going to kind of wrap up our session here. So if this requires you to go to your kitchen to seek some inspiration, feel free to do that. Let's take like 3 minutes, 4 minutes with this. Wow, really great responses already. This is stuff we could have totally used. This is nice. You peeking in these, Christopher? You can see these?
Sorry, I was muted. Yes.
Mm-hmm.
And then realized I couldn't see you because I was looking at the screen, so you might not be able to see me.
Measuring cups, classic, but this one's a fun twist on them. 2/3 cup, 1.5 cup, 3/4 of a cup. That I need to see.
Sarah and I are we're the same person. I'm convinced.
You and Sarah?
Yeah, I have that set. Love it. Man, that moment when you need 2 cups of something, and you just pull out the 2/3 cup, and you're like, I'm doing it 3 times. Feels so good.
That's some next level usage. Shout out to Sarah's fruit fly example. The fruit fly population, we're talking exponential increasing, exponential decay.
Yeah, we got some good handful estimation kind of stuff. Grab a handful of kidney beans. Make a guess first, count second.
Really fun. Really, really fun. So much more fun that it's like in your kitchen and you're about to eat it than, in a jar somewhere and you can't touch, sort of a thing.
Yeah, the tactile experience. The Tupperware with the spatial visualization required both to store it, like to get all those plastic containers. The one-to-one correspondence between containers and tops, and then the spatial visualization around my wife, we don't eat a lot of takeout food. My wife, Rachel, she is very loath to throw stuff away for environmental reasons. And I'm with her on that almost all the way. But so takeout containers now, evidently there are the thing is now the black plastic bottom, which is not recyclable. You can't recycle black plastic. And then it's got the little cool lid on top. And there's at least 2 different manufacturers of the rectangular ones, like with rounded corners, and the rounded corners don't match up. So it's not just the rectangular one with the rectangular top. It's the right rectangular one with the correct rectangular top. top.
Shout out to Christopher's hexagon toys, and I feel like you should make a Tupperware toy. Like Tupperware sponsors you. Different Tupperware bottoms, different Tupperware tops.
Nice.
Love this. The coffee pot as a place for ratios, water to bean ratio. Michelle, my wife, is always making. We used to both drink from the same coffee pot, and now I have a separate coffee routine. But she still makes the same amount of coffee. So I'm gonna have her watch this hour-long recording later. Maybe we'll debrief. We'll talk about it.
Some math ideas, sweetie.
So I'm still trying to reconcile the pour over coffee ratios, which are totally different than the coffee pot ratios, and I'm still wrestling with that one. I'm the person that always ruins the pot because I like my pour over and I try to make them similar.
Yeah, it's tough. Okay. Well, I think we just kind of shouted out some of the ones, but we are more than happy to, we'll find a way to compile these and maybe attach these in the notes on the way out, because we think a lot of these ideas are great, and we appreciate you taking the time to write and share them. We would love for everyone to get a chance to see how much fun this was from our end. Closing thoughts? Why don't we go Molly, Christopher, me?
All right, sorry, trying to unmute here. So hopefully, I'm just hoping from today that you're walking away starting to maybe have more attention to the ways in which you're already mathematizing, and maybe find out a little bit about your family and the way that they like to mathematize. I do have to share these controversial eggs because so I am not in my own kitchen. And I've decided now that egg moires must be like dishwasher moires, like you don't want to mess with someone else's eggs. Well, these are my sister-in-law's eggs. I don't know if you can see those. Oops. Those are shells on the left. My egg is the one egg that's missing there. And I now feel like I have to eat this entire carton because I discarded my shell and didn't keep it in the package. So with that, I hope you learn something new about yourself or find out something new and mathy about your family members.
I'm not certain that everyone here has fully understood the exact situation that went down in that household today. Molly reached into the refrigerator, pulled out a carton of eggs, and half of them were actual eggs and the other half were the shells that someone had used the eggs and put the shells back into the carton and the whole carton back into the refrigerator. I've never heard of this before, and I hope that I never hear of it again.
Egg carton mores are strong. I'm convinced they're passed down. Like, must be someone's family ancestors that stored eggs in this way. So I'm trying not to mess with it, but
now I can't even remember what my closing words were. Oh no, I do remember. It's so one of the things that we have gotten a lot better at because yes, Latrenda, but does she not have a compost bowl? Latrenda says maybe she's composting. That's what the bowl is for. You put the can only compost they can only be composted in multiples of 18. I do appreciate the empathy, the reaching out in the attempt to understand. Whereas all I have in me is scorn. In all seriousness, we've gotten a lot better at the kind of activity that we've asked you to engage in, because we've spent a lot of time practicing it. It's a thing that looking for mathematical opportunities in the world and broadening our own vision past what we're used to seeing in elementary, middle school, high school, college textbooks, and thinking about just the ways that we can think mathematically that might be supportive of school, and that sometimes frankly might not be supportive of school, that encourage you to break rules to talk about perpendicular vertices, but all for the better of opportunities, and then we can make decisions about which ones we take and which ones we don't. But that idea of getting better at what we practice is really an important part of what we see in a presentation like this. Give you an opportunity both to practice your own thinking and to see the kinds of ideas that other people, not just us, but that other people will come up with in a space that's that's familiar to you, that feels comfortable, and that you understand. What math is there that you might not have seen? Every time we do it, we see mathematical ideas that we hadn't thought about, new ways of thinking about familiar ideas. So thanks for joining us for that today.
All right, and I'll keep my part short here. I think I just want to say, first off, echoing Molly and Christopher's sentiments, thank you for being here. Thank you for playing along. I think today I felt a really strong sense of, hey, we're out here in the public again. You know, we're hearing voices. I felt like people were talking to each other in as limited and constraining of a thing as a webinar. And so we really appreciate all of that. And we can't wait for public math to be a part of this like entry into the world, because we would love for there to be as many opportunities to play with math and play even just outside of math as much as possible. So thank you for being here, and thanks for playing along with us. We really appreciate it.
All right. I thank all of you for being here tonight. Thank you, Christopher, Chris, and Molly. We are glad that they were able to present. We're glad that you were able to be here. Just a couple of announcements. Our next session is on Tuesday, April 20th, same time, 9 p.m. Eastern time, or convert to whatever time zone you're in. That'd be an interesting math thing. How many time zones are represented here, and what's the difference in the times? But on April 20th, we're going to be hearing from Michael Pershin about why kids learn from examples and why other times they don't. It's a K-12 session, and I would encourage you to attend that if that's something that you're interested in. I also wanted to let you know that we're looking for Global Math Department webinar attendees to share how the Global Math Department has impacted their work in their classrooms. This webinar is going to have approximately 4 presenters sharing for 10 to 15 minutes each. We are interested in hearing from people that have attended the webinar live, those that have watched the recording, or those that have listened to the podcast. Consider sharing with us for this special session on June 29th. If you're interested, you can email us at globalmathdepartment@gmail.com, or you can fill out this Google form that I just put the link to in the chat. In addition, if you know of any potential speakers, please email us or have them email us at globalmathdepartment@gmail.com. Thank you very much, everyone. Have a lovely evening, afternoon, morning, wherever you are.